Hello everyone, welcome back to the Computer Network lecture. In this video, we'll continue our discussion from the previous chapter about network layer. But now we are going to be talking about the control plane in network layer. Okay, so this is our goals in this chapter. First, we'll try to understand the principles behind network layer control plane. The highlight of this chapter is we'll talk about the routing algorithm. Okay, and this is will be this is most of the content in this chapter will be talking about routing algorithms. And then when we have time, we'll talk about SDN controllers and how they are implemented. And again, if we have more time, we'll talk about the network management and configuration. Okay, so this is really like a bonus. Okay, so the SDN controllers can be compared with the traditional routing algorithms or routing protocols because it adds more flexibility in the way the routing is done. Okay, so first we talk about the basic principles. Now we all the concept. Then we will also have a look at the implementation in the internet. Okay, so first of all, we'll talk about two routing protocols, OSPF and BGP. So we'll talk about the details later, but there are two types of routing protocols. The first one is intra AS, and the other one is inter AS. Okay, so what is intra AS? AS is it stands for autonomous system. So autonomous system can be, the example of autonomous system can be ISP, or any organization that has its own networks, like universities, companies, and so on and so forth. So they are considered as one AS. Okay, so if the routing is done within the same AS, the same ISP, the same organization, then we can use this one of the very famous routing protocols is called OSPF. This is implementation of link state algorithm. We'll talk about that later. Okay, and for the inter AS, the communication the routing among different AS, we'll use BGP. This is the protocol stands for border gateway protocol. Okay, so we'll talk about that later. Why we need the inter AS protocols when we already have the some routing algorithms, and then they are implemented in several routing protocols. All right, so moving on to the SDN, there are several terms, several technologies that are used. First of all, is OpenFlow. This is a protocol for communication between SDN controller and the SDN switches. And then there are several implementation of SDN controllers. For example, ODL, Open Daylight Controller, and NOS. Okay, or it is called or it stands for Open Network OS. All right, so this is again some bonus if we have more time. Internet Control Message Protocol, or ICMP. This is, I think, you are quite familiar with that. It is used, or it is the protocol behind ping command that we normally use. Okay, and also traceroute command. And for the network management, we have SNMP, Simple Network Management Protocol, and netconf and YANG is for the network configuration. Okay, so this is our outline or plan for this chapter. First, introduction, and then, as I said before, this will be the highlight of this chapter. Routing protocols. We have two types of routing protocols: link state and distance factor, and then implementation of routing algorithms. One is OSPF, and then what we call as intra AS or intra ISP. It's not just ISP actually. Also routing for inter AS or among ISPs is BGP, one of the state-of-the-art implementation. And then we talk about the SDN control plane, another approach of the per router control plane in network layer. And when we have time, we'll talk about the ICMP and the network management. All right, we have talked about that these things in the previous chapter and also in the earlier chapters, but we'll just repeat that. There are two important functions in network layer. The first one is forwarding, and this is in data plane because it's really deal with the packet, the incoming packet, and how and where we forward this the packet. Okay. And routing, it is really the process that is done in control plane, because it's a process to plan the route. Okay. And to know what is the best path. Okay, so it cannot be done at the same time when the packet is coming into the router. Okay, so this is a different process with the data. And then we also talk about this. There are two approaches in the structuring network control plane. The first one is per router control, which is a traditional or like a legacy system where the control plane and data plane, they are in the same system or in the same device, like the router that we all seen. And then the second one is logically centralized control. So this is the approach in software defined networking, or SDN. So per control plane, without taking a long time, we have the control plane and data plane in the same router. Okay, so this is like the router that you have seen in the packet tracer. They are using this approach. Okay, so basically the control plane, they are doing, I mean, it is doing the routing algorithm, and the result of the routing algorithm is local forwarding table. So this forwarding table will be used by the data plane, okay, to forward the incoming packet. Okay, in the SDN control plane approach, the control plane is not in the same device or with the data plane. So rather it is implemented or located in the remote controller. I mean, they can be, just one. I mean, they are called a centralized controller, but then in implementation, they can be also distributed, okay, among several controllers. Okay, so that's so basically some introduction about the control plane. Before we go into specific link state and distance vector algorithms, we'll discuss a little bit about the routing protocols. Okay, so the goal of routing protocol is to determine the good paths or routes, basically, from sending host to the receiving host. So basically from sender to receiver. Okay, through network of routers. So basically this is now we include another component in the networks. We already talked about it previously, but then now we'll see more function of the routers. Okay, besides just a forwarding. So the path is sequence of routers packets traverse from given initial source host to final destination host. So for example, like uh, a sender from this client laptop, okay, it wants to communicate with the one server in this network. Okay, so each router will determine what is the good path for this packet from source to destination. Okay, and then a definition of good. Okay, because we talk about the good path, I mean, it's just we can define any matrix or any parameters. It could be least cost. I mean, the general way of saying the good path is least cost, and the cost can be defined as, let's say, shortest path. Okay, fastest means that the minimum delay and least congested, and so on and so forth. Let's say we can find, several routing paths with the shortest path. But then if that routing paths are you I mean if that is used by several flows, then there will be congestion. So that's not I mean, it's not good path anymore, because it becomes congested. Okay. And routing is a top 10 networking challenge. Okay, so besides what we already discussed before, besides the congestion in the network. Okay, so this is the general graph as abstraction in when I mean, or the term that we use in routing. So first, we have the link cost. Link cost is represented by directed, not directed, I mean, undirected graph. Okay, the graph consists of the node and edge. Okay, N is set of routers. Okay, and in this example, we have U, V, W, X, Y, and Z, and we have set of links that connects two routers between two routers. We have links between U and V, U and X, V and X, and so on and so forth. And then between two links in one link or between two nodes, we can have the cost of the link or link cost. Okay, so what we I mean notation will is written by C A comma B. Okay, C A comma B means the cost of the link between A and B, or direct link between A and B. Okay, if there is no direct link between A and B, then the cost will be represented by infinity. Okay, so for example, like cu comma z, since there is no direct link between u and z at the moment, then this will be represented by infinity. Later on, when we run our routing algorithm, then somehow we'll find the path between u and z. Then we'll I mean, so basically, when we talk about the link cost, then if there's no direct path, the link cost will be infinity. So that's it. Okay, so we don't talk about the path cost. Okay. Now we'll talk about the routing algorithm classifications. So we have four quadrants. Okay, the first axis is whether it is global or decentralized information. I mean, when we talk about the decentralized, the opposite will be centralized, but this is not in that sense. Okay, so we'll see about that later. Um, Global means that all routers have complete topology, link, and link cost info. So the way the information is processed and computed is still done individually by each router. Okay, it's not done by a central entity, and then it is distributed to all the routers. But the way the information about the topology and the link cost is known by each of the router is different than the decentralized mechanism. Okay, in this case, all routers have the same information about the link cost info and the network topology, and it has the global network or the complete network topology. And this is one of the algorithms is the link state algorithms. Okay, and then we have the decentralized algorithms. Uh, okay, in this classification, routing algorithm classification, with each node doesn't have the complete topology of the networks, and also it doesn't also have the information about the link cost info. It relies on its neighbors to exchange the messages through iterative process until all the nodes reach the convergence situation. So in that case, all the nodes have the same information about the link cost and the topology. And um, the algorithms that fall in under this classification is distance vector algorithm. So we'll talk about these two mainly. We'll talk about these two algorithms. And then in the how fast the routes changes, we have static and dynamic. So basically, it really depends on the type of the networks. Okay, for example, like if we talk about the wireless networks, then it's really dynamic. Many nodes come and go, so it's a dynamic. The routes change more quickly. And then what we have to do with the routing is that we have to change the configuration of the routing, like how many times do we need to update. Okay, and then periodic updates or response to link cost changes. Okay, and static, normally in like the wired network, and when the load is not that high, we can have the static routing. Because yeah, maybe in some networks that has very high loads, they may need to add more nodes to increase the capacity. Then the network will be changed, but still the change is not as fast as the wireless networks. So I think that's it about the routing classification. Then in next video, we'll talk more about the link state algorithm and distance vector algorithm. So see you again in the next video.